Hey guys, how's it going? Here's a quick example of how we can approach the cooldown for today. Again, your cooldown's accessed here. Unit 3, Lesson 3, when we open it, it's going to look something like this. What we want to do is write solutions to this equation. Look, Miss Cedillo's even on here already. We're going to write a solution to the equation x squared equals 5 in two ways. First, using exponents. Second, using radicals. And then the second problem, write the cubed root of 78 using exponents. So I want to give a second example of this type of problem. So it says, write a solution to the equation x squared equals 15 in two ways. First, we'll do it using exponents. So what we're looking for is really one number times itself, which is what squared means. That's going to be equal to 15. Might help us to think, well, this 15 is really just 15 to the first power. That exponent isn't necessary, but it's going to be helpful right now. Whole numbers probably won't work. Like if I were to put 3 squared, well, that equals 9. I'll write that up here actually. 3 squared is equal to 9. So I know that. But also, if I were to think of the next number, 4 squared is equal to 15. Or sorry, 16. Not what we want. 4 times 4 is 16. So we're close. Seems like the number has to be some fraction or decimal value between 3 and 4. I'm not sure though. But in class, we learned a way that we can write this. Building off of the exponent here, something squared to make it 1. Well, if I start with 15, do this different color. I have a base of 15 because I want that base 15. We learned that the power of a power property tells us we can multiply the exponents. So for example, we could have 15 to the 1/2 power. 1/2 times 2 is 1. Therefore, this works. 15 to the 1/2 squared is equal to 15 to the first. So we have a solution, x equals 15 to the 1/2. We'll solve that equation. We learned in class today that there's another way to write these rational exponents. So when we have a fraction in the exponent, we can write it using radicals. Again, radicals are anything where we use this symbol. This symbol is called a radical. We have different meanings for it. We can have different indexes in this radical. Like if we don't write anything, we're assuming that the index here is a 2, which means a square root. However, we can change it. In a radical, we could write a 3. That means a cube root. We could change it to a 4. I mean a fourth root. I could change it to 100. That would mean the 100th root. That would be asking me what number times itself 100 times would equal whatever number we have inside, like maybe 10. What number times itself 100 times equals 10? I don't know. But we can rewrite fractional exponents like this, 1/2, as a radical. 15 to the 1/2 power is just equal to the square root of 15. So again, on this radical, since I did not write a number right here, I'm assuming it's a square root. So technically it's a 2 right here. Don't write the 2, you don't have to. We're just going to leave it as the square root. We can prove this works. If I were to write it, square root of 15 squared. Well, we've learned in the past that square roots and squares, well, they're inverse operations. So a lot of people say they cancel. Well, really, this is 15 to the 1/2 power. They cancel because it just equals 15. 15 to the first power. So the square root of 15 squared is 15. All right, and the next problem says, write the cubed root of 87 using exponents. So we just mentioned this cubed root. Well, it's going to come across pretty similar to this. The square root of 15 was equal to 15 to the 1/2 power. Well, cube roots are the same idea, but instead of the 1/2 power, this 3 is going to tell us that denominator of the fraction. So when I have the cubed root of 87, we can write it with fractional exponents. So this would be 87 to the 1/3 power. So instead of 2 in the denominator now, like we had up here, our fraction in the exponent is now 1/3. So point is, we can write our solutions in two different ways, using exponents or using radicals. All right, I hope this helps. If you have any questions, feel free to come to office hours, and I will help you out.